Morning Math 8, and welcome to your second to last assignment for the year. I decided to put the assignment first on the forum today so we don't get confused. This will be left blank, so when you open your Google Doc, this is your assignment. You won't have to scroll down to the end, it's just whatever's blank up top here. So you're going to complete the two-way table up here, and then you're going to turn it into a relative frequency table, which we are going to learn how to make today. Okay, so that's your assignment there. So hopefully there will be no questions about what the assignment is or where to look for it. So, and then answering the question, is there a relationship between enjoying science and enjoying ELA? Because our table's about science and ELA here. Is there a relationship between students who enjoy one versus enjoying the other? Is someone who enjoys language arts more or less or equally likely to enjoy science? So that's like a realistic question to consider, and that's kind of the purpose of our lesson today. So without further ado, we will get started on looking at this. So we're going to take the table we talked about yesterday with what core people were in if they answered yes or no to a certain question. And we're going to just take this table and we're going to turn it into what's called a relative frequency table. So that instead of talking about the actual numbers, we'll turn it into percents. So basically what that means is I'm going to pick one variable to be independent variable, and I'm going to put that one, well, I'm just going to make sure I label it. So, or that'd be like your x-axis, or like time is your x-axis, like whatever. Basically, you want to see if, I want to see if I change someone's core class, will that affect like how well they answered this question? Like if I was like, oh, my core 4 kids, maybe I didn't do a topic as well with them, or maybe I forgot to mention something one day. Maybe they will do worse on this question than others. Like, is that the case? So we are going to go ahead and actually get rid of one of our total columns. So if I'm looking at my independent variable as core, I'm going to keep that total, and I'm actually going to end up getting rid of this whole column over here. I'm just going to put a strike through. That way you know, I'll just search help for strike through and put a cross through. So I'm going to ignore all that. And basically what I'm going to do is I'm going to write my relative frequency table. I'll leave my numbers here for now, but I'm going to write them as pieces of the total. So the 7 is going to be 7 out of 7, which is 100%. Because 7 is my total number of kids who are in core 4. And then 5, same thing. 100% of the kids in core 5. And then for core 6, it was a 4 out of 4 with 100%. Now what I'm going to do is I'm going to compare each piece to the total below it. So I'm going to use the total that occurs below that number and write my numbers as fractions. 4 out of 7, 3 out of 7. And basically what that means is, 3 out of 7 kids in core 4 said yes. And here I had 4 out of 7 kids in core 4 say no. So in core 5, okay, I had 4 out of 5 kids say yes, and 1 out of 5 kids say no. And in core 6, I had 3 out of 4 kids say yes, and I had 1 out of 4 kids say no. So what I'm going to do now is turn these decimals into percents. So I'm going to start with the core 6 actually, because these are easier. So 3 out of 4, hopefully we're okay with understanding that is 75%. And 1/4 is 25%. But really to get our percents, you want to divide the numbers and multiply by 100. So 4 divided by 5 times 100. 4 out of 5 is 0.8, which is 80%. 1 out of 5 is 20%. 3 out of 7, let's see, 3 divided by 7 is, hold on, what's your calculator? So we're going to Desmos.com scientific. And for 3 out of 7, I'm going to do 3 divided by 7, and then times 100. That's how I'm getting my percent numbers. So that's what I did for 4 out of 5. So 4 out of 5 times 100. That's how I got the 80. So there's my number. So 3 out of 7 is 42.85% or 43%. And then 4 out of 7 is 0.57. So times 100 is going to be 57%. So 57%. See, whenever I multiply by 0, just move the decimal point. Multiply by 10, sorry, not 0. So then 4 out of 7 is 57%, and 3 out of 7 is 43%. So let's go back to wherever I left off, and I have no idea which tab that was. It was not that one. That one. I've already forgotten the numbers. Oh, 43% and 57%. So now we're going to compare our data. I'm going to delete everything I don't need. Delete this, I guess. I'll delete that. So now I'm going to see, in my table, I want to see if there's a relationship going across. The kids who said yes, is that the same across the board? Are they approximately the same numbers? Does saying yes to the answer to this question dependent on what core you're in? In this case, I know that 80% in core 5 said yes, and 75% in core 6 said yes. Those are pretty close. So that one I'd be inclined to say, like, not really. So hold on, let me give a page break. Okay. So for 5 and 6, 75% and 80% is pretty close. So I'd say no relationship there. But core 4 only had 43% of kids say yes. So in this case, it does look like yes, because the percent was so different for core 4, it seems to think that something different happened in core 4. But, so core 4 had a much lower yes percent. So it seems that core 4 was more likely to answer no than the other classes. And conversely, you could also say, answer yes, not no. You could also look at the answering no. In core 5, 20% said no. Core 6, 25% said no. All right, those are both like not large numbers. But here, over half the kids in core 4 said no, so that's like a problem. That's like, okay, clearly that's different. So okay, you can see that for core 5 and 6, like not really. They pretty much got the same thing. Like they got the same, like those numbers are to be expected. Those variables don't seem to be related too much. All right, those would be other things that play, causing some kids to say yes and some kids to say no. But in core 4, there must be something different going on because more of them said no, like significantly more said no, and significantly less said yes. So that's really the goal of what we're looking at. We're looking across, well, okay, so if we have our total column rows down the bottom, we're looking across the rows to see, do different classes give different results? So we're looking at a couple more examples of the same exact questions, making more tables, and then you're going to do the exact same thing for science and ELA up here. You're going to fill in the table, you're going to make a total row, and then is there a relationship? Okay? So let's look at the instrument ones. I think I might have changed one of these tables a bit, but don't worry about it. So let's see, we have people who play an instrument and stuff like that. So here's our frequency table and our relative frequency table. Another page break. Okay, So you have these two. And I'm going to take these two tables and I'm going to write the bottom one as a relative frequency table. So again, the 26 is my 100%. Well, yeah, I'll do it later. So here, I really have 18 out of 26 and 8 out of 26. And I'll strike through this column. Command Shift S. Nope, that wasn't right. Don't know what that's doing. Command Option S. I don't know how to do it. Damn. Okay, I'll have to look for strike through again. Oh no, what happened? Describe my issue. Oh dear. Could take a very long time. Okay. Where is my strike through? S-T-R-I-K. Command. Oh, X, not S. Okay, Command Shift X. I'm gonna get rid of that total. Like these two are pretty like whatever when you want to choose. You can. I'll just keep the totals at the bottom. I think it's easier. So then 18 out of 26, 8 out of 26. Then we're at a 19 over here. So 12 out of 19 and 7 out of 19. So we're gonna go back to our calculator and figure out all those fractions. And remember, 26 out of 26 is 100%, and 19 out of 19, that is also the 100% there. So we're going to look at people who, or all these percentages to figure out if there's a relationship. Like, are people who play a sport more likely to play an instrument, not less likely to play an instrument, stuff like that. So let's see, our math, okay. Decimal calculator. So you have 18 and 8 out of 26. So you have 18 divided by 26 times 100. Then we have 8 out of 26 times 100. Right, we got 69% and 31%. And then we have 12 and 7 out of 19. So 12 out of 19 and 7 out of 19. Okay, so 69, 31, 63, 37. Okay, never remember that. 69 and 63. And then 31%, and really, the percents also have to add up to 100. 69 and 31% add up to 100. So if I forgot what the answer was, let's see, 63 plus, well, 30 plus 37 is my percent there. If you have more than one, like if you have more than two options, there's a chance the rounding might not add up to exactly 100, it might add up to 99, or if two different things rounded up, it might round to 101%. Don't worry about that too much. Just do your best rounding. If it adds up to like one off, like it is what it is. That'll probably happen with our questionnaire data on Friday, but don't worry about it, because it's fine. So now we have our percents. Now here we notice that of all the kids who play an instrument, 69% of them play a sport. And of all the kids who don't play an instrument, 63% of them play a sport. So I could say here, is there a relationship between playing an instrument and playing a sport? And I'd probably say no. Because if a kid plays an instrument, there's a 69% chance he plays a sport. And if he does not, he, she, whatever, this kiddo does not play an instrument, there's a 63% chance it plays a sport. So basically, here, these numbers are fairly close. They're off by 6%. You could say a kid is 6% more likely to play an instrument, to play a sport if they play an instrument, Like that's just kind of like a social thing. Like some kids, if they're into something, they want to try everything, and some kids, if they're like not into something, they don't want to try other things. Like that's just like kind of a way it is. Like you're like really involved or not so involved. It's just sometimes the way it is, but not typically. Um, so we see there's like not really a huge connection. Both these numbers, 69 and 63, are fairly close to each other. So we can see that in this case, our variables aren't really related. There's not much of a relationship between playing an instrument and playing a sport. Because when I split up my totals like this, when I consider only like the total of kids who play instruments, there's not a huge difference between if I compare just kids who play an instrument, like if I split up the population and say, oh, look at kids who play instruments, 69% of them play a sport. Okay, cool. But if I look at kids who don't play an instrument, 63% play a sport. Those are pretty close together. It's really not that different. So we would say there's not really a relationship. Comparing playing an instrument versus not playing an instrument doesn't make a big difference. So let's look at the spicy food one again. That's fun. I'm always one row short. Very last example, we can do this one probably quickly. But again, if I make this into a relative frequency table, it's the same numbers. No, they're not the same numbers. So again, if I look at this, I can turn these numbers into percents. And that total is 6. Really, the trick with these is making sure you're using the right total. Again, eating spicy food and eating ranch blue cheese, one of those is not really going to be in charge. Command Shift X, got it, awesome. So let's see, I know this happens to be 67%, 2 out of 6 happens to be 33%, that's 100%. So we've got nothing else out of this lesson. At least on the bottom row has to be 100%. And they're going to be fractions and percents. Let's see, 16 out of 26 and 10 out of 26. Let's see. All right, let's get a calculator. 16 divided by 26. 62%. 61.53. So rounds up to 62. Oh, hold on. Yeah, 61.5. So we got 62%. And then 10 out of 26 has to be 38%. So again, in this case, is there a relationship between like so who prefers ranch or blue cheese? People who eat spicy food, typically, 62% of them prefer to eat ranch versus blue cheese. And people who don't eat spicy food, 67% of them prefer ranch over blue cheese. So again, there's not a huge difference in our percentages. Like the ranch population is still the majority, and the percentages aren't that different. So we would say there is not, what in the world is that? Not really a relationship between spiciness preferences and ranch versus blue cheese preferences. And some of you are like, Mr. Oberto, both of those things are disgusting. Like, yes, I understand. Not everyone likes those, but that's just a question. All right. So, hopefully that helps you, at least in making the table, and hopefully interpreting it. Some of the interpreting stuff I know gets a little confusing. I taught actually the interpreting stuff for the first time last year, so hopefully you guys are going to get better than I gave it to the kids last year because they did not like how I taught it at all. So hopefully that gives you enough help to go back and try the original one. Does enjoying ELA versus science like have a relationship with each other or not? So I'm going to go ahead and I'm just going to strike through this column over here because we didn't set them up like this at all. We're just going to set it up like this. So go ahead and finish this table. You have to finish this with your totals. And then you're going to have to complete that side of the table or strike through this. You complete the relative frequency table here with percents. So let's bold it, let's capitalize, let's italicize it, let's make it pink. with percents and fractions. Yeah, show the fractions the guy the percent, so I know you set them up right. And then, is there a relationship? Are students who enjoy ELA more, less, or equally likely to enjoy science? All right, so I hope that was helpful. Remember, if there is a relationship, that means like these numbers are very different. Like something's affecting the other. Like there's something there that's making things different. Like in core 4, 5, and 6. Core 4 had much fewer yeses. So something must have caused that class to have less yeses. Whereas 5 and 6 had the similar number of yeses. So like there's no relationship between 5 and 6 and saying yes. But since core 4 had such a lower number of yeses, there was something there that must have affected it. Okay? So that's probably the best example to look at from the class. So make sure you understand that one. Go ahead and fill out this doc. There's no form today, just this. So I'll just be glancing at these real quick to make sure people know what they're doing / are actually doing it. And that's pretty much it. So enjoy your day, and I'll see you Friday.